In this video, we will talk about how the Linux security module framework works and how it is deployed. Thus, the various LSM implementations available. The main features of SE Linux explain the different modes and policies available, grasp the importance of context and how to get and set them, how to use the important SE Linux utility programs, gain some familiarity with the AppArmors. Let's begin. What are Linux security modules? A modern computer system must be made secure, but needs vary according to sensitivity of the data, number of users with accounts, exposure to outside networks, legal requirements, and other factors. Responsibility for enabling good security controls falls both on application designers and Linux kernel developers and maintainers. Of course, users have to follow good procedures as well, but on a well-run system, non-privileged users should have a very limited ability to expose the system to security violations. Here, we are concerned with how the Linux kernel enhances the security through the use of the Linux security modules framework, particularly with the deployment of SE Linux. The idea is to implement mandatory access controls over the variety of requests made to the kernel, but to do so in a way that minimizes the changes to the kernel, minimizes overhead on the kernel, permits flexibility and a choice between different implementations, each of which is presented as a self-contained LSM, Linux security module. The basic idea is to hook system calls, insert code whenever an application requests a transition to kernel system mode in order to accomplish work that requires enhanced abilities. This code makes sure permissions are valid, malicious intent is protected against, etc. Right? It does this by invoking security-related functional steps before and or after system call is fulfilled by the kernel. Main LSM choices. For a long time, the only enhanced security model implemented was SE Linux. When the project was first floated upstream in 2001 to be included directly in the kernel, there were objections about using only one approach to enhance the security. As a result, the LSM approach was adopted, where alternative modules to SE Linux could be used as they were developed and was incorporated into the Linux kernel in 2003. The current LSM implementations are SE Linux, AppArmor, SMAC, and Tomoyo. LSMs are now considered as either major or minor when configuring their combination. We will concentrate primarily on SE Linux and secondarily on AppArmor in order of usage volume. SE Linux overview. SE Linux was originally developed by the United States NAS, National Security Administration, and has been integral to Red Hat Enterprise Linux for a very long time, which has brought it a large use base. Operationally, SE Linux is a set of security rules that are used to determine which processes can access which files, directories, ports, and other items on the system. It works with three conceptual qualities, right? Um, Context, rules, policies. Contexts are labels to files, processes, and ports. Examples of context are SE Linux user, rule, and type. Rules describe access control in terms of context, processes, files, ports, users, etc. Policies are a set of rules that describe what system-wide access control decisions should be made by SE Linux. A SE Linux context is a name used by a rule to define how users, processes, files, and ports interact with each other. As the default policies to deny any access, rules are used to describe allowed actions on the system. Additional online documentation can be found in the SE Linux users and the administrator's guide. SE Linux enforcement modes. SE Linux can be run under one of the three modes. enforcing, permissive, and disabled. For enforcing mode, all SE Linux code is operative and access is denied according to policy. All violations are audited and logged. Permissive mode enables SE Linux code but only audits and warns about operations that would be denied in enforcing mode. Disabled mode completely disables SE Linux kernel and application code, leaving the system without any of its protections. These modes are selected and explained in the etc sysconfig SE Linux, CentOS, and OpenSUSE, or etc SE Linux config Ubuntu, right? The SE status utility can display the current mode policy. Get enforce and set enforce. To examine or set the current mode, you can use get enforce and set enforce, right? Set enforce can be used to switch between enforcing and permissive modes on the fly while the system is in operation. However, changing in or out of the disabled mode cannot be done in this way. Well, set enforce allows you to switch between permissive and enforcing modes. It does not allow you to disable SE Linux completely. There are at least two different ways to disable SE Linux. Configuration file. Edit this SE Linux configuration file, usually etc SE Linux config and set SE Linux equal disabled. This is the default method and should be used to permanently disable SE Linux. Kernel parameter, add SELinux equals 0 to the kernel parameter list when rebooting. However, it is important to note that disabling SELinux on systems in which SELinux will be re-enabled is not recommended. It is preferable to use the permissive mode instead of disabling SELinux so as to avoid relabeling the entire file system, which can be time-consuming. SE Linux policies. The same configuration file that sets the mode, usually etc sysconfig SE Linux, also sets the SE Linux policy. Multiple policies are allowed, but only one can be active at a time. Changing the policy may require a reboot of the system and a time-consuming relabeling of the file system contents. Each policy has files which must be installed under etc SE Linux type. The most common SE Linux policies are targeted, minimum, and MLS. The targeted is the default policy in which SE Linux is more restricted to targeted processes. User processes and init processes are not targeted. Well, network service processes are targeted. SE Linux enforces memory restrictions for all processes, which reduces the vulnerability to buffer overflow attacks. Minimum, a modification of the targeted policy where only selected processes are protected. MLS, the multi-level security policy, is much more restrictive. All processes are placed in fine-grained security domains with particular policies. Context utilities. As mentioned earlier, contexts are labeled applied to files, directories, ports, and processes. Those labels are used to describe access rules. There are 4 SE Linux contexts: user, rule, type, level. However, we will focus on type, which is the most commonly utilized context. The label naming convention determines the type context labels should end with _t, right? As in kernel_t. You use the -z option to see the context. You use change con command to change context, right? SE Linux and the standard commands. Many standard command line commands such as ls and ps were extended to support SE Linux, and corresponding sections were added to their man pages explaining the details. Often the parameter z is passed to standard command line tools as in ps axz. Another command you can run is os-z home temp. Other tools that were extended to support SE Linux include cp, mv, and mkdir. Note that if you have disabled SE Linux, no useful information is displayed in the related fields from these utilities. Context inheritance. Newly created files inherit the context from their parent directory, but when moving files, it is the context of the source directory which may be preserved, which can cause problems. Continuing the previous example, right, we see the context of a temp file was not changed by moving the file from a temp to home Jamie. Here's the command we're going to use. First, the section on the screen, right? And also we can do the second section of the screen and the last one then. So the classical example in which moving files creates a SE Linux issues is moving files to the document root directory of the HTTP server. On SE Linux enabled systems, the web server can only access files with the correct context labels, creating a file in temp and then moving it to the document root directory will make the file inaccessible to the HTTP server until the SE Linux context of the file is adjusted, okay? RestoreCon resets the file context based on the parent directory settings. RestoreCon resets the default label recursively for all files out of the home directory. This is the command you're going to use. RestoreCon-rv home Jamie, right? When you do ls-z to verify that. Note that the context for temp file has been reset to the default context for files created at the home directory. The type was changed from user temp t to user home t, right? SE manage. Another issue is how to configure the default context for a newly created directory. SE manage f context provided by the policy core utilities Python package can change and display the default context of the files and the directories. Note that the SE manager f context only changes the default settings. It does not apply them to existing objects. This requires calling RestoreCon afterwards, right? Here's an example on the screen. You do mkdir virtual hosts, and then you list it with -z, and then you do se manage f context -a-t http d _sys _content_t / virtual hosts, right? And then you list it again, right? Then you restore -rfv / virtual hosts and list the folder again, right? So the context changes from default t to httpd. This content -t is thus only applied after the call to the restore con. Use SE Linux booleans. SE Linux policy behavior can be configured at the runtime without rewriting the policy. This is accomplished by configuring SE Linux booleans, which are policy parameters that can be enabled and disabled. Get SE bool to see booleans. Set SE bool to see booleans. SE manage boolean -l to see persistent boolean settings, right? You can see what you need to do to list all booleans of the current policy, including the current status and the short descriptions. Monitoring SE Linux access. SE Linux comes with a set of tools that collect issues at a runtime, log these issues, and propose solutions to prevent same issues from happening again. These utilities are provided by SE troubleshoot-server packages, right? When you do the troubleshooting, you can turn on the tail, right? Tail bar log messages to dig further, okay? AppArmor. AppArmor is an IOSM alternative to SE Linux. Support for it has been incorporated in the Linux kernel since 2006. It has been used by SUSE, Ubuntu, and other distributions. AppArmor provides a mandatory access control MAC, allows administrators to associate a security profile to a program which restricts its capabilities. It is considered easier by some, but not all, to use than SE Linux. It is considered a file system unnatural or no security labels required. AppArmor supplements the traditional Unix discretionary access control DAC model by providing mandatory access control MAC. In addition to manually specifying profiles, AppArmor includes a learning mode. in which violations of the profiles are logged, but not prevented. This log can then be turned into a profile based on the program's typical behavior. Checking status. Distributions that come with the AppArmor tend to enable it and load it by default. Note that the Linux kernel has to have it turned on as well, and in most cases, only one LSM can run at a time. Assuming you have the AppArmor kernel model available on the system D equivalent system, you can do a sudo systemctl start stop restart status AppArmor to change your inquiry about the current state of operations, or do sudo systemctl enable disable AppArmor to cause to be loaded to or not loaded at boot. In order to see the current status, the sudo AppArmor status, profiles and processes are in either enforce or complain mode, directly analogous to SE Linux enforcing and permissive modes. Note that in a process listing of PID is given to you to ps aux pap grep libvirt d. Modes and profiles. Profiles restrict how executable programs which have path names on your system, such as user bin evidence, can be used. Processes can be run in either of the two modes, enforce mode and the complain mode. Enforce mode applications are prevented from acting in ways which are restricted. Attempted violations are reported to the system logging files. This is the default mode. A profile can be set to this mode with AA enforce. Complaint mode. Policies are not enforced, but attempted policy violations are reported. This is also called the learning mode. A profile can be set to this mode with AA complaint. Linux distributions come with pre-packaged profiles, typically installed either when a given package is installed or with an AppArmor package such as AppArmor profiles. These profiles are stored in etc apparmor.d. When installing new software, new policies can be created specific to any executable in the package. Exactly what AppArmor profiles are installed on your system depends on your selection of software packages, right? AppArmor utilities. AppArmor has quite a few administrative utilities for monitoring and control. For example, on the OpenSUSE system, you can run rpm-qil appamor-utils pap grep bin. And know that many of these utilities can be invoked with either their short or long names, right? And you also can take a look at the form on the screen. Those are the AppArmor utilities, right? Those are about their program and the use. Okay, this is the end of this video. Thank you for watching. I'll see you in the next one. Bye for now.